Greetings. Today I will be discussing the expressions and equations domains for grades 6 through 8. This domain is one of the most important areas of middle school math because it serves as a bridge between arithmetic and formal algebra. When everyone asks me what math I teach, I'd be like the foundation for all math. So I look forward to getting into this with you all. The expressions and equations domain focuses on helping students transition from working with numbers to working with variables and relationships rather than learning just procedures. Students begin recognizing patterns representing unknown quantities and reasoning about mathematical relationships. According to the textbook, the goal is for students to understand why procedures work instead of memorizing steps. This conceptual understanding becomes essential as students move into Algebra 1 and higher level mathematics. Each grade level contains clusters that organize related standards around a common math idea. In 6th grade, students began connecting arithmetic with algebraic expressions and equations. 7th grade focuses on properties of operations to create equivalent expressions and solve complex problems. 8th grade shifts towards analyzing linear relationships and understanding functions, which are essential concepts in high school algebra. The clusters help teachers see how individual standards connect to larger mathematical ideas instead of teaching isolated skills solo. I used the Georgia standards. So one strength of the Georgia standards is how they intentionally build from one grade to the next. In 6th grade, students are introduced to algebraic thinking by writing and evaluating expressions and solving simple equations. 7th grade expands on those skills as students simplify expressions, apply the distributive property, and solve multi-step equations and inequalities in the real world. By 8th grade, students begin working with linear equations, functions, and slope, preparing them for Algebra 1. Each year builds directly on the previous year's understanding. So this proves that if students do not grasp what they need to in the year before, they will continue to struggle with math as they progress. For my task, I chose a task from the illustrative mathematics called Ticket to Ride. In this activity, students are told that Malia purchased 14 tickets for an amusement park and each ride costs 2 tickets. So the students must first write an expression representing the number of tickets remaining after riding a certain amount of rides, which is our variable, and then create another equivalent expression. The most important part of this task is that students do not stop after writing the expressions. They must interpret what each number and each part of the expressions are within the context of the story. This moves students beyond the procedural fluency and requires them to connect algebraic expressions to a real-world situation, which is our focus with what we're teaching. Because students explain their reasoning and compare equivalent expressions, they develop a deeper understanding of algebraic structure rather than simply just moving symbols around. Although this task supports several mathematical practice standards, the primary connection comes in with Mathematical Practice 7, Look for and Make Use of Structure. The illustrative mathematics explains that students learn how equivalent expressions can reveal different information about the same situation. Even though 14 minus 2x and 2 times 7 minus x produce the same value, each expression emphasizes a different way of thinking about the problem. One focuses on the number of tickets remaining while the other focuses on the number of rides remaining before multiplying by 2 tickets per ride. This task also supports other mathematical practices as listed. MP1, because students must make sense of the problem before writing an expression. It connects to mathematical practice 2 as students reason between the context and the symbolic expressions. Also, mathematical practice 3 by explaining why the expressions are equivalent and defending their interpretations. Lastly, they use mathematical practice 6 by communicating their reasoning with accurate mathematical vocabulary and precise explanations. This task reflects the goals of the expressions and equations domain because it emphasizes conceptual understanding, reasoning, and mathematical communication, opposed to simply just applying procedures and getting the problem done. So there are some common misconceptions that occur. One of the most common is that students will interpret the equal sign as meaning the answer comes next, instead of understanding it is just a symbol of balance. Students frequently combine unlike terms, such as 3x plus 4 equals 7x. And the distributive property comes with a lot of mistakes because students forget to multiply every single term inside of the parentheses. They'll only do the first term. When it comes to integers in this manner, students are introduced to integers in 7th grade, so negative numbers have a difficult understanding when solving equations, and many students misuse the order of operations when simplifying expressions because the use of multi-step equations is just now being introduced to them. Recognizing these misconceptions allows teachers to address them before they become a long-term misunderstanding. I spend a lot of time in my classroom trying to correct these issues from the misunderstanding prior, and I found that please excuse my dear Aunt Sally is cool and all, but it helps if they just write PEMDAS because they can see it letter by letter instead of please excuse my dear Aunt Sally. It doesn't work for them. It's too much. So the textbook by Miles and Williams places emphasis that effective instruction goes beyond just showing the students procedures. Students should use models, visual models such as algebra tiles, number lines, and balance models to develop conceptual understanding of the domain. Teachers should encourage mathematical discussions where students explain and defend their reasoning. Asking students to justify every step strengthens their understanding of mathematical properties. A productive struggle is always beneficial and should be encouraged because it helps students build perseverance and deeper conceptual understanding instead of relying on memorized steps. Students demonstrate understanding of the expressions and equations domain when they can do more than simplify expressions or solve equations. They should be able to represent a real-world situation using variables, explain what each part of the expression means, recognize when two expressions are equivalent, and justify when they are equivalent using mathematical properties. The Ticket to Ride task is a strong example of this because students create an expression for the number of tickets Malia has remaining and then generate another equivalent expression. They must explain what the numbers, coefficients, and variables represent in the context of the problem. For example, students explain that 14 represents the number of tickets Malia started with. 2x represents the tickets used after a certain amount of rides. And 2 times 7 minus x emphasizes the number of rides remaining rather than the number of tickets left. This demonstrates conceptual understanding because students connect algebraic structure to a real-world context and explain why different expressions represent the same situation. This type of reasoning is exactly what the expressions and equations domain is designed to develop. Instead of memorizing procedures, students show they understand algebra by interpreting, justifying, and communicating their mathematical thinking.